Welcome to Cosmic Sleep Science, where we drift through the universe's mysteries beneath a starry veil. Tonight, we explore 3I Atlas, an interstellar guest that may linger in our solar system, rewriting cosmic tales. Settle in. Let the night's calm embrace you, and listen as space whispers secrets. On October 29th, 25, astronomers caught a fleeting signal. The third interstellar object spotted by the Vigilant telescope system designed to guard Earth, named 3 Atlas. This wanderer revealed a rare trait, a trajectory suggesting it could orbit our sun for years, not vanish swiftly. This window of maneuverability stunned observers, hinting it might linger like a guest pausing at a cosmic crossroads. Unlike brief visitors, its path offers a chance to stay, a puzzle unfolding slowly. Imagine a traveler hesitating at your gate, hinting at tales from afar. This moment sparked wonder, turning routine scans into a profound invitation, urging us to ponder its purpose, a riddle etched in the vast unknown waiting to be solved. Early estimates size the object at 20 kilometers wide, dwarfing earthly cities with its immense bulk, a small world adrift in the void. This scale, drawn from its faint shimmer and orbital wobble, shocked scientists. As such, giants should be rare, yet it slipped in unnoticed. Its presence challenges our cosmic maps, suggesting unseen realms. Picture a colossal statue appearing in a familiar field. Its origins a mystery. Why so large? Why now? The object's mass hints at secrets carved in its surface, perhaps craters or clues from distant systems. This anomaly invites curiosity, urging us to explore a cosmic enigma, its vastness a whisper of truths waiting to unfold in the silent expanse. The chance of encountering this visitor is slim, roughly 1 in 10. Thousand years for such a body to pass so close. Space is vast, systems scattered like islands across an endless sea, making such events rare. Yet, this object defies the odds, arriving as if chosen by fate. Imagine winning a rare prize twice in a lifetime, unexpected yet undeniable. Its timing stirs question. Could the universe be busier than we thought? This rarity, a cosmic stroke of fortune, captivates the mind, suggesting a purpose behind its journey. The improbability pulls us closer, urging us to seek answers in a fleeting guest. Its presence a puzzle glowing with promise in the boundless unknown. Compared to earlier visitors like Oumuamua and Borisov, this object stands apart. The 2017 wanderer, cigar-shaped, sped through silently, while the 2019 comet trailed dust. Familiar yet foreign, this new arrival blends traits, yet lingers with a precise path, too neat for a drifter. Picture a guest resembling family, but speaking in unfamiliar tones. Staying longer, unlike its kin, it seems to pause, drawn to our system's rhythm. This hybrid nature sparks intrigue, hinting at origins beyond our grasp. Perhaps a realm with different rules. Its differences weave a tale, inviting us to explore a cosmic mystery. Its journey a thread connecting distant worlds to our own in the quiet void. Cosmic distribution favors small objects, like pebbles outnumbering boulders in a stream. Yet this visitor, a 20-kilometer giant, defies the pattern. Smaller bodies should swarm before such titans appear, but this one arrives alone, upending expectations. Imagine finding a massive tree in a field of saplings, its presence unexplained. Why skip the smaller kin? Perhaps our models miss hidden flows, or this object follows a unique path. Its size suggests a cosmic exception, a story untold in our charts. This anomaly challenges assumptions, urging us to rethink the universe's rhythms, to seek truths in a puzzle that looms large, waiting to reveal its secrets in the vast silence. The object glows far beyond Jupiter, at 5 astronomical units, where sunlight fades to whispers. Telescopes caught this shimmer, a beacon in the outer reaches, defying the dimness of distant realms. Most bodies there lie dormant, yet this one shine, hinting at an inner spark. Picture a lantern glowing in a fog, unlit by nearby flames. This radiance, so far from warmth, suggests unusual properties, perhaps unique materials or processes. Why does it glow so soon? The light marks a cosmic clue, pulling us to question its nature, to chase a truth that flickers in the emptiness, ready to unveil its hidden story. Typical comets, icy relics from our system, awaken only near the sun, their gases flaring into bright tails. This visitor, however, shines far from solar heat, its radiance defying the usual script. It glows as if stirred by an inner force, not external warmth. Imagine a dreamer rising before dawn, eyes alight with unseen visions. Why break this pattern? Its early glow suggests a different makeup, perhaps exotic ices or energies unknown. This quirk challenges our models, hinting at a nature apart from comets. The anomaly beckons us to explore, to uncover a secret pulsing in a cosmic enigma, waiting to be understood. Could this object shine from within, like a cosmic ember with its own energy? Spectra hint at strange chemistry, perhaps radioactive decay or unique outgassing, fueling a glow not borrowed from our sun. It's no blazing orb, yet carries a subtle fire. Unlike typical drifters, picture a creature in the deep, glowing without surface light. This possibility thrills, suggesting origins in alien realms, perhaps forged in distant furnaces. Why such radiance? The idea of self-luminosity marks it as extraordinary, a puzzle with its own pulse. This clue invites us to dream, to chase a truth shimmering in a wanderer's heart, ready to reveal its cosmic tale. The object's orbit hugs the ecliptic plane, where planets align in a cosmic dance. Most wanderers arrive at wild angles, chaotic from foreign tugs, yet this one glides neatly, almost too perfectly. This alignment, a 1 in 500 chance, feels deliberate, like a guest joining a parade. Imagine a clock's hands meeting at noon, their precision no accident. Why such harmony? Its path suggests a connection to our system, not random chance. This synchronicity stirs wonder, hinting at unseen forces guiding its course. The precision pulls us to explore, to seek a truth woven in a cosmic thread, waiting to unravel its purpose. The 1 in 500 odds of such a tidy orbit stun, as random paths should scatter wildly, like leaves in a storm. This visitor, however, threads our planetary plane, its course too neat for chance. Picture a key fitting a lock you never knew existed, opening new questions. Why this alignment? Perhaps unseen currents steer it, or it mirrors a distant system's design. This improbability suggests intent, not accident. Challenging our cosmic maps, the anomaly captivates, urging us to trace its journey, to uncover a reality hidden in a precise arc, ready to shift our view of the heavens. This visitor's traits, its size, glow, and orbit, weave a pattern too striking for chance. A 20-kilometer giant, shining early, aligned with our planets, it defies random drift. Each clue, from its 1 in 10, whose unrival to its steady path, feels like a deliberate stroke. Imagine a letter arriving, its words too perfect to be unplanned. Is it a natural relic or something more? A messenger from afar. Its lingering orbit suggests intent, a guest choosing to stay. This puzzle stirs the mind, urging us to seek a truth pulsing in a cosmic enigma, waiting to unveil its hidden meaning. Astronomers gauge the interstellar visitor's size by analyzing its faint glow, captured through sensitive telescopes scanning the heavens. By measuring sunlight reflected from its surface, they assume a typical albedo for icy bodies, calculating dimensions based on brightness intensity. Early observations suggested a staggering 20 kilometers, a behemoth dwarfing earthly landmarks like sprawling cities or vast islands. This method, reliable for comets, depends on predictable surface properties, but the object's shimmer fluctuates oddly, hinting at unusual materials, perhaps exotic ices or metallic sheen. Picture a distant ship revealed by its lantern, yet its form remains elusive, cloaked in mystery. The technique offers a glimpse into its nature, but the glow raises questions, suggesting a composition beyond our familiar charts. Why such an erratic light? This puzzle stirs a quiet thrill, urging us to peer closer, to unravel a cosmic enigma whose radiance hides secrets waiting to be unveiled in the vast unknown, a truth shimmering just beyond our grasp. Ready to shift our understanding of the cosmos, initial estimates peg the visitor at 20 kilometers wide, a size that disrupts cosmic probabilities with its sheer scale. Such giants should be exceedingly rare, yet this one emerged without warning, challenging our models of interstellar traffic. In a universe where smaller bodies dominate, this titan stands out, like a mountain rising abruptly in a quiet valley. Its dimensions suggest a population of large wanderers we've overlooked, skewing our statistical expectations. Why no earlier sightings of smaller kin? The odds of such a massive body arriving soon after prior visitors feel like a cosmic fluke, defying the expected rhythm. This anomaly hints at gaps in our understanding, perhaps unseen currents guiding larger objects our way. Imagine stumbling upon a colossal relic in a familiar field, its presence unexplained. The object's scale sparks wonder, urging us to question our cosmic census, to seek a reality hidden in a giant's frame, waiting to reshape our view of the heavens' boundless flow. Nature's distribution law predicts thousands of tiny objects, mere meters across, swarming like dust motes before a giant appears. Yet, this visitor, vast in scale, arrives alone, defying the cosmic pattern that favors smaller bodies. This upends our expectations, suggesting either a skewed flow or a unique journey. Imagine panning a river for pebbles, only to pull up a boulder, its presence startling. Why no smaller precursors? Perhaps our theories miss hidden pathways, or this object follows a distinct course, bypassing the usual scatter. Its arrival hints at a universe bending its own rules, sending titans without prelude. This break from the norm challenges our models, urging us to rethink the rhythms governing cosmic travelers. The anomaly pulls us to explore, to uncover a truth etched in a massive puzzle, its solitary presence a clue waiting to emerge from the endless void, ready to redefine our cosmic perspective. Hubble's sharp lenses adjusted the object's size to 6 kilometers, a more modest yet still striking figure, based on clearer images and spectral data. This refinement eases the statistical strain of a 20-kilometer giant, yet a 6-kilometer body remains a rarity among wanderers. Picture a fortress, once thought a towering citadel, now a grand keep, still imposing. Why did it evade earlier detection? The new estimate fits better within cosmic odds, but its sudden appearance puzzles astronomers, suggesting unusual traits or origins. Could its surface hide unique properties? This adjustment sharpens our focus, yet leaves questions unanswered, hinting at a nature beyond our charts. The data invites scrutiny, urging us to probe deeper, to chase a reality shimmering in a cosmic enigma's refined outline, waiting to unveil its hidden truths in the vast unknown. Even at 6 kilometers, the object stands out, far larger than most interstellar visitors, with odds of such a size occurring once in thousands of years. Smaller bodies, like seeds scattered in a field, should dominate, not boulders like this one. Its presence feels out of place, a guest arriving unannounced with uncommon grandeur. Could it signal a hidden group of larger wanderers? Or something more deliberate? Imagine a single monument rising in a village, its purpose unclear, drawing every eye. This rarity sparks intrigue, suggesting forces or origins we haven't grasped. Why such a sizable traveler? The anomaly challenges our cosmic senses, urging us to dig deeper, to seek a truth pulsing in a massive enigma, its scale a hint, waiting to shift our understanding of the heavens' quiet flow. The visitor's steady path and lack of gas jets deepen its mystery, as comets typically release gases near the sun, nudging their courses with subtle bursts. This object, radiant far out, shows no such activity, yet its trajectory remains precise, hugging the planetary plane. This stability suggests a heavy, unmoved body, unlike typical comets. Picture a ship sailing true through a storm, ignoring turbulent wave. Why no gaseous flares? Its ecliptic alignment hints at a guided course, not random drift. The absence of jets puzzles scientists, pointing to a dormant surface or unique makeup. This quirk stirs questions, urging us to explore a cosmic riddle, its unwavering arc a clue waiting to be decoded in the boundless expanse. Ready to reveal its secrets, unlike comets, the object lacks extra acceleration from gas jets, moving solely under gravity's pull. Previous wanderers showed such nudges, but this one's course is steady, implying immense weight or an inert surface. Picture a boulder rolling straight, untouched by breezes that scatter lighter stones. Why no jets? This suggests a dense core, perhaps metallic or rocky. Unlike porous comets, the anomaly challenges our models, hinting at a nature beyond standard expectations. Possibly extraordinary. Could it be more than ice and dust? This stability captivates, urging us to probe a cosmic puzzle, its resolute path a whisper of truths waiting to emerge from the vast unknown. Ready to reshape our cosmic view, calculations peg the object's mass at 33 billion tons, a staggering figure drawn from its size and steady trajectory. This weight, far beyond typical comets, suggests a solid core, anchoring it against gas-driven shifts. Imagine a mountain drifting through space, unmoved by cosmic currents. Why so heavy? It could be a fragment of a shattered world, or something stranger. With a density hinting at unusual materials, this heft defies comet norms, challenging our understanding of interstellar travelers. The figure sparks awe, suggesting origins we can't yet fathom. It urges us to chase a reality in a colossal enigma, its mass a clue waiting to unfold in the silent void, ready to shift our cosmic perspective. The object's 33 billion ton mass overshadows earlier wanderers, which weighed millions to billions of tons. A 1 synonym to 100 dozen-fold difference. This gap stuns, as interstellar bodies should cluster smaller, not tower like this. Picture a cathedral rising among modest huts, rewriting the landscape's scale. Why such a titan? It suggests a unique origin, perhaps a broken planet or a crafted relic. The contrast with its kin challenges cosmic norms, hinting at unseen populations or deliberate design. Why so massive compared to others? This disparity pulls us to question, to seek a truth in a towering puzzle, its weight a whisper of secrets waiting to emerge from the boundless expanse, ready to redefine our view. What if the object is hollow, its mass suggesting a thin shell rather than a solid core? A hollow structure, like a lightweight frame, could mimic high weight with low density, resembling artificial constructs. This fits its steady path, lack of jets, and size. Picture a lantern, strong yet light, glowing within. If crafted, it could explain its odd traits, hinting at technology from afar. Why such a form? The idea thrills, suggesting a relic or probe disguised as a comet. Could it be engineered? This possibility captivates, urging us to dream of a cosmic enigma, its hollow heart a clue waiting to unveil truths in the silent void. The object's surface might be cloaked in ice or CO2, masking a denser core. This coating could mimic a comet's glow, hiding materials beneath, perhaps suppressing gas jets to explain its steady course. Picture a figure in a veiled cloak, blending into a crowd unnoticed. The ice might be natural, formed in a cold realm, or deliberate, concealing something extraordinary. Spectral hints of odd compounds deepen the mystery, suggesting a hidden nature. Why such camouflage? This disguise sparks intrigue, urging us to peel back layers, to seek a reality in a cosmic puzzle. Its surface a hint waiting to reveal secrets in the vast unknown. The visitor's size: 6 kilometers, and 33 billion-ton mass defy comet norms. Its steady path and lack of jets suggesting something beyond chance. Picture a puzzle piece fitting perfectly. Yet from an unknown gain, is it a natural fragment or a crafted object? Its traits align too neatly, hinting at intent over randomness. The anomaly, from its precise course to its heft, challenge our models, urging us to rethink what travels the void. Could it be more than a comet? This mismatch captivates, pulling us to explore a cosmic enigma, its presence a whisper of truths waiting to reshape our understanding of the heavens' silent flow. The interstellar visitor glides near the ecliptic plane, where planets orbit in precise harmony. This alignment, with a 1 in 500 chance for a random object, feels strikingly deliberate. Most wanderers tumble chaotically, their paths skewed by distant gravitational pulls. Yet this one slots neatly into our system's rhythm, like a guest joining a choreographed dance. Why such precision? The odds suggest more than chance, perhaps a guided course or a mirrored origin. Picture a needle threading a tapestry, each stitch intentional. This anomaly sparks wonder, hinting at unseen forces shaping its journey. The visitor's path invites scrutiny, urging us to unravel a cosmic puzzle. Its alignment a clue waiting to weave a truth that reshapes our understanding of the heavens. The object's trajectory brushes close to Mars, Venus, and Jupiter. A sequence with a 1 in 20 is an improbability for random travelers. Such precision, threading through planetary paths, feels like a calculated weave, not a cosmic fluke. Random bodies should drift aimlessly, not align with our system's giants. Imagine a traveler visiting 3 landmarks in perfect order, each stop planned. Why these worlds? The alignment suggests a purposeful course, perhaps tied to our system's structure. This improbability stirs intrigue, hinting at a design beyond chance. The visitor's nearness to these planets pulls us to question, to seek a reality hidden in a cosmic pattern. Its trajectory a thread waiting to unravel secrets in the vast unknown. On October 3rd, 2025, the body passed within 29 million kilometers of Mars, a cosmic whisper of proximity. This close approach, rare for an interstellar guest, sparked intense interest, offering a chance to study its surface under Martian light. Its path, grazing so near, feels too precise for chance, like a ship skimming an island's shore. Why Mars? Why this moment? The flyby suggests an interaction, perhaps revealing clues in its texture or glow. This event captivates, a fleeting moment to glimpse a wanderer's secrets. The encounter urges us to watch closely, to chase a truth in a cosmic arc, its nearness a hint waiting to unfold in the silent expanse. NASA's Mars Reconnaissance Orbiter, equipped with its HiRISE camera, will scrutinize the visitor during its Martian pass. This high-resolution lens, capable of spotting fine details, could capture surface features, perhaps craters or unusual marks. Scientists hope to discern its composition, maybe exotic materials or patterns. Picture a painter sketching a distant figure, each stroke revealing more. The data could confirm size or hint at something extraordinary. Why such a close look? This observation offers a rare window, a chance to decode a cosmic mystery. The effort pulls us to focus, to seek a reality in a wanderer's visage, its surface a clue waiting to emerge from the vast unknown. The object's path risks crossing planetary orbits, a statistical rarity with slim odds. Aligning with Mars, Venus, and Jupiter requires precision, like threading a needle through moving threads. Analysis shows such intersections are improbable, defying the chaos of random wanderers. This suggests a shaped trajectory, not scattered drift. Picture a dancer hitting every mark in a complex routine, each step deliberate. Why such accuracy? The pattern hints at forces or intent beyond our models. This anomaly captivates, urging us to calculate its course, to uncover a truth in a cosmic weave. Its intersections a hint, waiting to reveal secrets in the boundless void. The visitor's trajectory, aligned with planets and ecliptic, feels meticulously tuned, with a 1 in 20,000 chance of random occurrence. Such precision, weaving through our system, suggests more than cosmic luck, perhaps a guided design. Random bodies tumble wildly, yet this one dances in step with our worlds. Imagine a symphony where every note lands perfectly. No errors. Why such harmony? The path hints at external forces, or a mirrored origin system. This possibility thrills, urging us to question chance versus intent. The trajectory pulls us to explore, to seek a reality in a cosmic puzzle. Its precision a clue waiting to unfold truths in the silent expanse. The close Martian pass, at 29 million kilometers, sparks theories of the object releasing a probe. This proximity offers a perfect window for a stealthy drop, a small device slipping into Mars's orbit unnoticed. Such a maneuver, bold yet plausible, fits the visitor's precise path. Picture a ship casting a message overboard, unseen by distant eyes. Why Mars? The idea suggests intent, perhaps a cosmic delivery. This speculation stirs excitement, hinting at a purpose beyond drift. The possibility urges us to watch closely, to chase a truth in a cosmic enigma. Its flyby a hint waiting to reveal secrets in the vast unknown. The object's course mirrors the orbits of Venus and Jupiter, grazing their trajectories with uncanny accuracy. This alignment, rare for a random traveler, feels like a nod to our system's rhythm. Venus's fiery arc and Jupiter's grand sweep frame its journey, as if it respects their gravitational pull. Picture a guest stepping in time with a familiar dance, each move precise. Why these worlds? The pattern suggests a connection, perhaps a design tied to our system. This echo captivates, urging us to trace its path, to seek a reality in a cosmic weave, its alignment a clue waiting to unfold truths in the boundless void. On October 29th, 2025, the body reaches its closest solar approach, with Earth obscured by the sun's glare. This alignment cloaks the object from our view, a cosmic curtain drawn at a pivotal moment. Such timing feels deliberate, like a performer slipping backstage. Could it shift its course unseen? The geometry suggests a window for subtle actions, unnoticed by our lenses. Picture a ship vanishing in fog, its next move hidden. This obscured moment sparks intrigue, hinting at intent. The event urges us to ponder, to chase a truth in a cosmic puzzle. Its timing a hint, waiting to reveal secrets in the silent expanse. The solar approach on October 29th offers the visitor a chance for a concealed maneuver, Earth's view blocked by solar brilliance. This blind spot, rare and precise, allows potential course changes or releases unseen. The timing, paired with its ecliptic path, feels too neat for chance. Picture a chess master moving a piece while eyes are averted. Strategy hidden. Could it adjust or deploy something? This possibility thrills, suggesting a purposeful design. The moment captivates, urging us to watch for clues, to seek a reality in a cosmic enigma. Its hidden window, a clue waiting to unveil truths in the vast unknown. When 3i Atlas appeared, the first reaction across observatories was caution. Many astronomers quickly labeled it as a comet, nothing more. Its faint green light, its elongated orbit, its gradual outgassing all seemed familiar. The human mind seeks patterns, and in the sky, patterns often mean repetition. To most researchers, this visitor fits the logic of nature rather than the signature of craft. They compare its motion to icy remnants from distant clouds, pushed gently by sunlight and gravity. For them, extraordinary claims demand extraordinary evidence. The cosmic visitor may intrigue the public, but within labs, skepticism remains the guardrail of science. They collect spectra, measure albedo, trace dust tails, and conclude that every feature has a natural cause. Yet even in this prudence, curiosity hums. If the object behaves like a comet but lingers too long, if its orbit defies expected deceleration, then perhaps nature still hides surprises we do not yet classify. The debate, though quiet, fuels deeper study. Every telescope becomes both a skeptic and a believer, staring into the same uncertain light. Avi Loeb's theory that 3i Atlas might be artificial stirred a wave of criticism. Colleagues called it premature, even theatrical. Some accused him of chasing headlines, of blending speculation with science. To them, such ideas risk public misunderstanding, feeding myths more than knowledge. Yet Loeb responds calmly, noting that bold questions have always sounded unreasonable at first. He does not claim certainty, only the right to wonder. Science, he argues, must walk the line between caution and curiosity. The backlash reveals not only skepticism but fear, the fear of stepping outside accepted models. Still, Loeb's persistence has value. It reminds the field that discovery is not comfort. If every claim must fit current textbooks, progress halts. The discomfort he creates may be the space where innovation grows. He does not chase sensation, he chases consistency, searching for where the data leads, even if it points beyond the familiar. The criticism may sting, but it also ensures that the conversation stays alive, and that the object above continues to invite new eyes to the sky. In every interview, Loeb repeats a single idea: follow the evidence, not the emotion. To him, belief is not a scientific tool. Data must lead. Even if it challenges our sense of what is possible, the universe, he says, is not obligated to align with human comfort. He points out that the light curve of 3i Atlas, its stable trajectory, and its energy balance hint at behavior not fully explained by natural processes. But rather than declare it alien, he invites testing. He demands more telescopes, more data, and more openness. He reminds his peers that rejecting a hypothesis before examination is not skepticism. It is prejudice. The discipline of science is built on patience, on allowing the unknown to teach. Loeb's message echoes across research halls. Humility before the cosmos. Every signal, every anomaly deserves inspection before judgment, whether this visitor proves natural or not. The act of looking without bias defines the essence of inquiry. For him, curiosity guided by data is the truest form of reason. In the early 20th century, Alfred Wegener proposed that continents move. His idea of continental drift was met with laughter and dismissal. Geologists called it fantasy, citing no known force strong enough to move land masses. For decades, his work lay in obscurity. his name whispered more as caution than inspiration. Yet time and new data turned ridicule into recognition. Plate tectonics now forms the core of Earth science. What was absurd became obvious. Loeb often cites Wegener's story as a mirror of today. He notes that ridicule is not a measure of truth, only a symptom of resistance. Innovation often arrives disguised as error. When faced with 3I Atlas, we might again stand at such a threshold. To dismiss the unfamiliar too quickly may be to delay understanding for generations. Wegener's continents did not stop moving while humans argued. Likewise, the cosmos does not wait for our agreement. It continues, patient and immense, waiting for eyes willing to see. Centuries ago, the idea that Earth moves around the sun was heresy. Galileo faced trial for suggesting motion where dogma demanded stillness. Later, the concept of black holes was treated as mathematical fantasy, an impossible solution to Einstein's equations. Yet today, both are pillars of modern understanding. These examples reveal a pattern. The universe often introduces truth in uncomfortable forms. Loeb draws from these stories not as proof but as reminder. Dismissing the improbable has cost humanity insight before. The lesson is not to believe every strange claim, but to remain open until evidence speaks. Just as the telescope vindicated heliocentrism, future instruments may clarify the nature of 3I Atlas. Each era guards its limits of imagination. What seems absurd today may be obvious tomorrow. The courage to question does not reject science. It strengthens it. Every accepted truth began as a doubt, and every doubt began as curiosity given time to breathe, to move beyond debate. Loeb proposes structure. He calls for an international organization dedicated to monitoring interstellar objects, neutral in politics and open in data. Such an institution would unite observatories across continents, sharing observations in real time. The goal is not to prove alien contact, but to ensure that no signal goes unexamined. Too often, discoveries fall into national or institutional silos, delaying verification. A shared system would remove secrecy and bias, turning observation into cooperation. Loeb imagines it as a planetary response team for cosmic visitors. When a new object enters the solar system, telescopes from Chile to Hawaii to the Canary Islands could synchronize within hours. The result would be global awareness, not rumor. Transparency would replace speculation. In this model, science becomes not competition, but stewardship. The cosmos is everyone's laboratory, and every anomaly deserves equal attention. Loeb's vision is practical, not romantic, built from the simple idea that the unknown belongs to all of humanity. Rather than trade opinions, Loeb insists on creating frameworks. A hypothesis, he says, is not a belief but a method to decide what 3I Atlas is. We must build systems that can test it. That means protocols for rapid observation, standards for data release, and shared criteria for classification. Without structure, debate becomes noise. Science must translate wonder into measurable terms. Loeb's proposal echoes this discipline. By defining how to question, we reduce confusion about the answers. The framework would guide how future anomalies are studied, how evidence is weighed, and how conclusions are reached. The purpose is clarity, not conviction. In this way, the conversation evolves from argument to architecture. The visitor becomes a case study for how humanity organizes curiosity. Each step of this process builds trust between institutions and across borders. The method itself becomes the discovery, a sign that our species can respond to mystery with reason rather than reaction. Loeb often repeats a phrase, better safe than sorry, to ignore the possibility of artificial origin. He argues, could be a historic mistake. The cost of looking and finding nothing is small. The cost of not looking and missing everything is immense. Throughout history, humanity has erred more by neglect than by excess curiosity. Diseases spread while warnings were mocked. Technologies stagnated while pioneers were silenced. If Three-Eye Atlas is natural, no harm is done by examining it. But if it is not, ignoring it could close the door to the greatest discovery of all time. Loeb's caution is not fear. It is foresight. He treats investigation as duty, not speculation. The skies do not send invitations twice. Missing one signal may mean centuries of silence before another arrives. Better to prepare instruments, coordinate observers, and risk being wrong than to stay blind and certain. In science, humility means readiness, and readiness begins with paying attention. A single telescope cannot capture truth. The universe demands collaboration. Loeb emphasizes that tracking Three-Eye Atlas requires a network of instruments aligned across the globe. Only through combined observation can we map its behavior in full. Clouds, daylight, and geography limit every individual sight, but together they form a complete eye. The idea mirrors the unity of science itself, built on shared vision. Coordinated observation would allow real-time comparison of spectra, motion, and energy reflection. Errors shrink, precision grows. Beyond the data, coordination fosters a new sense of planetary identity. Astronomers in different time zones become extensions of one mind, following the same traveler across the heavens. Loeb sees this as both practical and symbolic. It is not just about one object, but about learning to act as a single species in pursuit of knowledge. When the next interstellar visitor arrives, humanity must already be watching together, not debating in fragments. As the debate continues, one truth remains: Atlas is worthy of attention, whether comet or construct. It invites the same discipline of curiosity that defines science at its best. Loeb's insistence is not about belief, but responsibility. The cosmos has sent us a question, and ignoring it would be unscientific. The object's orbit, color, and endurance all ask for explanation. To study it deeply is not sensational, but sensible. Future generations will judge how we respond to moments like this. Did we listen, or did we dismiss? The path of knowledge is rarely straight, but every breakthrough begins with the decision to care. In the glow of telescopes turned skyward, we see more than data. We see a reflection of humanity's hunger to know. Atlas remains above, silent, indifferent, but its presence pulls our minds upward. Serious study is not belief, it is gratitude, the act of honoring the mystery by meeting it with attention and patience. When scientists calculated the number of interstellar objects that should exist, something strange appeared. The math did not fit. The sky revealed more travelers than models allowed. This mismatch became known as the mass budget problem. If every galaxy produces debris naturally, there should be limits. A predictable spread of fragments drifting between stars. Yet Three-Eye Atlas and its predecessors break that balance. Too many large objects, too little expected mass. It is as if the universe is sending more messengers than physics can afford. The equations strain under the weight of evidence. For every comet seen, there should be billions unseen. Yet telescopes do not find them. The result is a quiet paradox that unsettles astronomers. Something about the way matter leaves its birthplaces, or the way we search for it, is incomplete. The cosmos whispers a puzzle through statistics, asking us to rethink what we assume about formation, travel, and time. The odds of finding an object as large as Atlas moving through interstellar space are incredibly small. Standard models predict tiny fragments, dust grains, and frozen shards no wider than a city. To detect something hundreds of meters across is like catching a single snowflake in a storm that spans a galaxy. Statistically, it should not happen often. Yet it has, again and again. The models that once described a calm distribution of debris now seem too simple. Maybe our sampling is biased. Or maybe something unknown is shaping what we see. Probability collapses when the data grows stubborn. Astronomers run simulations, adjust inputs, tweak assumptions. But the numbers remain uneasy. It is as if nature is hinting that randomness is not enough, somewhere beyond our equations. There may be intention or unknown mechanics guiding the pattern. The more we measure, the more the sky behaves like a mystery that refuses tidy resolution. Before Atlas, there were two earlier guests. Oumuamua came first, a tumbling sliver moving faster than any comet known. Borisov followed, glowing like an ordinary traveler of ice. Together, they built the short history of interstellar arrivals. Yet their differences make the story stranger. One behaved like technology without exhaust, the other like nature without secrets. Between them and Atlas, a pattern forms but does not align. Each newcomer carries its own rhythm, its own refusal to conform. Oumuamua had no visible tail, yet changed speed. Borisov had a tail but came too soon for coincidence. Atlas lingers, orbiting longer than expected. The sequence feels irregular, almost scripted. Astronomers admit that three anomalies in quick succession challenge probability. If this is random, the universe has an odd sense of timing. These events force a re-examination of what moves through the interstellar medium and what motives may hide behind apparent motion. The first and simplest explanation is humility. Perhaps the models are wrong. Maybe the way we think matter travels between stars is outdated. The simulations assume that fragments escape planetary systems through gravity alone. But reality may involve complex tides, radiation forces, and unseen interactions with magnetic field. What if the galaxy is more crowded than our instruments can detect? What if objects drift in patterns shaped by ancient supernova winds, or the slow breathing of nebular clouds? To fix the mass budget, scientists may need to rewrite how ejection, erosion, and capture work across light years. Atlas could be part of a hidden population, unseen yet abundant. This view keeps the story within nature, but expands what nature means. It accepts that our understanding of cosmic dust, gas, and debris may be as limited as early maps of Earth's oceans. Beautiful yet incomplete, waiting for discovery to redraw their edges. The other explanation is harder to face. What if Atlas was made? Its persistence, its brightness curve, and its smooth motion suggest design rather than accident. If so, the mass budget issue disappears. Replaced by intent, a single crafted object can cross the void without the need for countless others. In this scenario, the galaxy may not be overflowing with debris but dotted with artifacts. Loeb hints at this possibility not as fantasy but as logic. If evidence resists natural fitting, artificial origin must stay on the table. The difficulty lies in proof. Without a close encounter or signal, the idea remains suspended between daring and doubt. Still, it offers elegance. A purposeful visitor explains rarity better than chaos. It turns probability into message, physics into story. Even if the truth remains distant, the possibility alone expands our imagination of what life and intelligence could do when given millions of years in a sky to cross. History shows that paradox is not failure but invitation. When numbers break, understanding grows. The ultraviolet catastrophe led to quantum theory. Mercury's orbit error revealed relativity. The missing neutrinos opened the door to new particle physics. Every time reality refused the equation, progress followed. The mass budget paradox may belong to this lineage. A small inconsistency can carry the weight of revolution. Loeb reminds his peers that doubt is the seed of clarity. By listening to the data rather than forcing it into comfort, science matures. Perhaps interstellar objects are to astrophysics what falling apples were to gravity. Simple events with hidden depth. What begins as confusion may end as coherence. The night sky has always been the canvas where paradox paints its first strokes, and through those strange patterns, knowledge finds its next form. Some researchers suggest that Atlas could be hollow. Its motion implies a mass lighter than expected for its size. A thin, possibly shell-like structure could explain its reflectivity and endurance. In engineering terms, this is efficient design. A hollow form minimizes mass while maximizing resilience. Spacecraft built by humans already use similar principles. Solar sails, satellites, and telescopes all stretch thin materials across wide frames to catch radiation. If the visitor shares this property, it hints at purpose. Natural objects rarely evolve such geometry. Hollow structures in space are unstable unless built. Yet to claim construction without proof is bold. So scientists study rotation, thermal balance, and spectral fingerprints for subtle signs. A hollow model fits the data better than a dense rock. The idea remains cautious, yet its technical echo is clear. Something in its shape speaks the language of function rather than chance. To move beyond debate, we need vision sharper than theory. The Hubble Space Telescope and the James Webb Telescope can both refine what we know. Hubble offers legacy precision. Webb offers infrared depth. Together they can dissect motion, brightness, and temperature with unmatched clarity. Loeb advocates coordinated observation, urging agencies to dedicate time before the object drifts too far. With Webb's sensitivity, even faint heat traces could reveal surface composition. If the visitor emits or reflects light in unusual patterns, the mystery tightens. Every photon holds information about material, density, and age. These telescopes are the eyes of a species trying to read a cosmic letter. The data they collect will not only test Loeb's hypothesis, but also expand catalogs for future encounters. Whether we find signs of technology or signs of nature's artistry, the act of looking binds curiosity to evidence, turning wonder into understanding. Even if Atlas proves natural, it remains extraordinary. Its stability, shape, and behavior point toward a category unknown in astronomy. Perhaps there exists a class of interstellar travelers forged under rare conditions. Icy fragments sculpted by radiation into mirror-like shells. Discovery of such an object would reshape planetary science. It would mean the processes that birth and eject matter are more diverse than assumed. New models would need to include delicate forms, low-density structures, and long-lived trajectories. A natural yet unfamiliar body bridges the line between geology and art. It would remind us that nature can mimic design, that complexity does not always require intention. Such realization enriches rather than diminishes wonder. To find a new family of wanderers is to add a verse to the poem of creation, one that we did not know the universe had written. In the end, the numbers tell a quiet story. They do not fit, and that imperfection is beautiful. The mass budget paradox, far from a flaw, becomes an invitation. When data exceed theory, awareness expands. Atlas stands as a reminder that reality is not bound by our frameworks. The universe operates with generosity, offering puzzles to those who listen. Loeb's approach is not belief, but openness, a willingness to let observation reshape certainty, whether artificial or natural. The visitor exposes the edge of our understanding. Beyond that edge lies possibility, the spark of a new paradigm waiting to form. Every equation that fails is a door. Every anomaly is a whisper of deeper law. As telescopes continue their silent walk, humanity learns once more that knowledge begins not with answers, but with the courage to face the unknown and remain awake to its quiet call. At the moment of closest approach, 3i Atlas drifted near the burning heart of the system, where distance collapses and gravity sings. Most wanderers from the interstellar dark accelerate here. racing outward again once the pull of the star releases them. But this one hesitated. Instruments showed a strange flattening in its velocity curve, as though some unseen hand slowed its fall. The numbers defied what comets should do. Instead of rushing through, it lingered, tracing an arc of quiet defiance. Astronomers compared the movement to a breath held midair. It seemed to wait, almost listening, suspended between freedom and belonging. Around that shimmering edge of sunlight, an ancient law appeared to bend. Something once thought transient began to show signs of staying. The sky did not shout, but whispered change. When a spacecraft fires engines near a star, the Oberth effect multiplies the thrust, turning fuel into a burst of speed. Yet motion can also bend backward. If a traveler releases energy in the opposite direction, it can use gravity not to accelerate but to slow. Observers noticed such a signature in Atlas's flight. Its deceleration looked calculated, precise, almost intelligent. No random tumble, no burst of dust, just steady, graceful loss of pace. Some imagined an invisible sail adjusting to solar winds. Others thought of an engineered probe guiding itself with perfect restraint. The sun's energy, usually a weapon for escape, now acted as a brake, like a dancer turning within light. The object curved inward, calm and exact. What we witnessed might not have been nature, but the art of control written across vacuum. When a body slows beneath the escape velocity, it no longer leaves. The star keeps it, wrapping invisible arms around its mass. Slowly, the newcomer's orbit shifted from open to bound. What was once a path of passing became a loop of belonging. Computers recalculated, and the result was impossible. The solar system had caught a traveler from the deep. It did not fall into the sun, nor flee into interstellar dusk. It settled, softly, between motion and stillness, like a leaf caught by a gentle stream. It followed the current into quiet return. Astronomers who studied the data spoke of gravity's kindness, a net woven by time itself. Every planet, every comet, every unseen rock became witness to an uninvited guest finding home. And in that silent capture, the familiar order of the heavens grew one layer deeper. Then came the passage no one could observe. As it neared the sun, 3i Atlas slipped behind the glare, lost to every telescope. The senses went blank. The sky turned white. The signal vanished. For half a day, the universe looked empty. That stillness was louder than sound. Scientists waited, eyes fixed on screen, wondering what the unseen hours concealed. Some said it might have rotated, adjusted, even transformed. Others stayed silent, aware that light itself can hide more than it reveals. When it re-emerged, the difference was small yet unmistakable. Its path was changed, slower, deeper, as though reborn from fire. The hidden side of the sun had left its mark. A curtain of light had concealed a quiet maneuver, and through that blinding gap, mystery grew roots when it returned to sight. The glow had softened, the reflection dulled, the color dimmed, and the pattern of light scattering shifted in ways no dust model could explain. Some called it an optical illusion. Others called it choice. For several days it disappeared again, slipping under the reach of wide-field arrays. When found once more, its motion traced a gentler rhythm, almost circular, almost deliberate. It had not escaped. Not yet. Around it, the planets moved as before, unaware that a stranger had joined their ancient dance. Astronomers whispered that the solar system had grown by one silent orbit. The interstellar guest had stopped running. It now drifted in balance, bound not by chance but by quiet intent. The visitor had chosen to stay beneath our sun. 3i Atlas performed any controlled maneuver near the sun. We would only know much later, during the weeks of November and December, when its faint glow returned beyond the solar glare. astronomers began to notice irregularities. The path it traced did not match the projected models from October. The difference was small, yet real, like the subtle drift of a leaf caught in a changing current. Observatories compared data across continents, and a pattern emerged. Its orbit had shortened, its period compressed. Something had acted near perihelion, but there had been no recorded outgassing, no thermal flare, no visible thrust. It was as if the space around the sun had concealed a whisper of motion. Such silence could only mean one thing: a deliberate change executed in shadow. The maneuver, if it happened, left no plume, no spark, only mathematics to prove it existed. This is how mysteries speak in astronomy, not with explosions, but with fractions of degrees. Numbers that tell the story long after light fades. What we saw in late November was not just a comet returning from fire. It was a traveler carrying the memory of something done unseen. If there was control, then what powered it? Some speculated on sails so thin they shimmer only when sunlight bends, catching photons like invisible wind. Others imagined micro-engines that release ion streams, measured in milligrams of thrust, yet steady enough to shape entire trajectories. A few dared to whisper of nuclear drives, small cores built for centuries of operation, guiding silent voyagers through cosmic emptiness. None of these theories felt impossible, only distant. Humanity itself has sent probes with such ambitions, though never with such elegance. Atlas moved without noise, without flare, conserving energy like a being that knows endurance. No trace of heat, no radio signal, no reflection of intent, and yet everything about its motion felt intentional. Perhaps what we call technology is only one language among many forms of intelligence. A grain of dust could hold memory. A mirror could think, and light itself could serve as fuel. The line between artifact and organism blurs in such speculation. We search for engines, but maybe the engine is the object. Maybe what moved Atlas was not machinery, but design woven into its structure, like instinct written in stone. The sun offers a narrow window where forces can invert. The same gravity that accelerates can also absorb motion if timed with precision. This is the essence of a reverse Oberth effect, a maneuver almost mythical in its difficulty. To slow near a star, one must act at the exact heartbeat of energy exchange. Too early, and the push throws you outward. Too late, and the pull consumes you. Atlas seemed to choose perfectly. It vanished into the solar glare and emerged months later, moving slower, looping tighter. There was no flash, no trace of fuel, no wake of vapor. It was as if the star itself became part of its control system. Imagine a surfer not resisting a wave but folding into it, losing speed while still staying afloat. The reverse Oberth is such a dance, the act of turning gravity into resistance. To human science, this is still theory. To a traveler that learned to listen to stars, it could be routine. Whatever happened near the sun was not chaos. It was choreography, a silent maneuver hidden beneath brilliance, waiting for months to be seen. When the data from December came in, analysts noticed a lasting alteration. The change was small in numbers, yet vast in implication. Its velocity had decreased by a fraction, enough to alter centuries of trajectory. Instead of a fleeting guest, it became a slow wanderer within the solar neighborhood. This is how capture begins, not with suddenness, but with quiet persistence. Over years, such a shift reshapes the map of space around us. A single maneuver near the sun could bind an object for millennia. The new orbit showed an elongated ellipse, grazing the paths of the outer planets before circling back inward. It was neither random nor temporary. The mathematics spoke of stability, a motion that learns to rest. Some called it a miracle of celestial mechanics, others something guided. Either way, it was lasting. Once momentum changes, time itself adjusts to the new rhythm. The interstellar traveler had altered its fate through the smallest act of restraint, proving that in the language of space, even stillness can be power. There is a concept in astrodynamics known as self-anchoring. It is the idea that an object, once slowed within a gravitational field, can maintain balance without continuous propulsion. Planets do it naturally, but artificial bodies could learn the same harmony. Atlas seemed to embody that principle. By allowing its momentum to soften, it found a place within the sun's reach where it could drift indefinitely, neither escaping nor falling inward. This idea fascinates scientists, for it represents mastery of gravitational dialogue. To be anchored is to belong. Yet to remain free, it is the art of using a star's pull as home rather than hazard. For a species or a machine built to travel between suns, self-anchoring could mean survival. It would turn every star into a harbor, every system into a resting point. Atlas may be the first to demonstrate this on a scale we can witness. To stay is not weakness. In cosmic term, it is wisdom. A choice to pause amid endless motion. Looking back, the date of October 29th becomes more than a calendar entry. It marks the instant when paths diverged. Before that day, 3i Atlas was a stranger from beyond, following the cold laws of interstellar motion. After that day, it became something else, something that listened to the sun and decided to remain. The universe rarely grants such turning points. They are like whispers between gravity and intention, brief yet eternal. In human stories, such a moment would be called awakening. In science, it is data, angle, and velocity. Yet behind those numbers lies something tender, a trace of will. The object did not crash or flee. It adapted. October 29th will be remembered as the day our understanding of visitors changed. A silent maneuver, hidden by light, transformed an interstellar fragment into a companion of the sun. The cosmos turned a page without sound, and a new chapter began, one that speaks of presence, of staying, of quiet choice among the stars. By early October, as 3i Atlas crossed the inner regions of its new path, Mars became the perfect vantage point. The Mars Reconnaissance Orbiter turned its instruments toward the faint emerald glow that trailed the visitor. In the quiet of interplanetary night, the spacecraft gathered streaks of data, each photon a clue from an alien trajectory. The red planet, usually still and indifferent, now served as our distant outpost of curiosity. Engineers recalibrated sensors, pushing beyond their original design, trying to separate truth from artifact. For days, the signal shimmered faintly, constant yet delicate, suggesting the traveler was intact, perhaps rotating slowly, reflecting sunlight from polished surfaces or frozen dust. It was hard to tell. Through that thin stream of numbers came a feeling shared among scientists, the sense of witnessing something both ancient and new. The orbit of Mars had turned into a window on a stranger's face. Every reading hinted that the story of October 29th was not finished. The silence of deep space had begun to answer, not in words, but in light. HiRISE, the powerful camera aboard the Mars orbiter, offered resolution sharp enough to distinguish objects meters across. When directed at Atlas, it revealed a subtle difference between the glowing cloud that surrounded it and what appeared to be a darker, denser nucleus. The coma rippled like mist, yet the core stayed steady, almost geometric. That observation sparked quiet debate. Could the center be metallic, angular, or perhaps structured by design? Natural bodies rarely hold shape after passing near a star, yet this one seemed untouched. Some models even suggested rotation consistent with a stable frame, not the random spin of a cometary fragment. The image, faint and grainy, carried more weight than words. It implied endurance, intention, or at least resistance to disintegration. HiRISE had seen what no Earth-based telescope could during that period, the divide between surface and shroud. And in that divide, the question deepened. What if the outer haze was not coma at all, but shielding? A deliberate layer masking an inner machine. The idea was not proof, only possibility. But for astronomers who dream of contact, possibility is enough to keep watch. As the calendar moved toward winter, the great observatories of humanity prepared. The Hubble Space Telescope aligned first, steady and old, its instruments tuned for precision over glamour. Soon after, the James Webb joined, its infrared eyes capable of cutting through dust and glare. Together they formed a duet of vision, old and new, watching the same faint object moving against the starfield. At the same time, ESA's JUICE mission, built to study Jupiter's moons, prepared to gather side data as Atlas drifted closer to the giant planet's domain. Never before had so many instruments focused on a single interstellar body with such coordination. The purpose was simple: to catch its return, to see whether its glow remained steady, whether spectra changed, whether motion matched prediction. Each image sent back was like a heartbeat from something distant. The observatories had become listeners, not just watches. Between November and December, the silence of space filled with patient attention. The story of Atlas was no longer a mystery told in theory, but a collaboration written in photons, shared across the world's greatest eyes. By early 2026, 3i Atlas's path would bring it within the outer neighborhood of Jupiter. The Juno spacecraft, orbiting that vast world since 2016, might become an unexpected observer. Its sensors, designed for plasma, field, and particle studies, could record the subtle magnetic ripple of the object's passing. The chance alignment is rare, like two drifting ships crossing in the same current of darkness. If Juno detects ionized trails or changes in the magnetosphere, it could confirm that Atlas interacts with sunlight in controlled ways. That would mean propulsion, or at least intention. The gas giant's gravity provides a slow stage where even faint forces reveal their pattern. Scientists already simulate the possible approach, tracing the geometry of observation, hoping to catch a glimpse through Juno's camera suite. Whether the data comes in as a spike or a silence, both outcomes will speak. In the deep rhythm of orbits, 2026 stands as the next key. Jupiter will be the mirror, Juno the witness, and Atlas the moving question, framed against the storming marble of the largest planet. To follow an object that may think or act is not the task of one nation or one telescope. It requires the patience of many watchers scattered across Earth, sharing sky and time. A global observation campaign is already being drafted, stretching from Chile's desert plateaus to Hawaii's mountain domes, from Canary Peaks to the cold plains of China's observatories. Each station will capture a small slice of the same unfolding story. Data must overlap, must build a continuous map of position, color, and brightness. If 3i Atlas performs another maneuver, the change may last only hours. Miss that window, and truth slips away again. Coordinated coverage becomes essential, a kind of astronomical heartbeat that never stops. Amateur astronomers, too, will join, their lenses tiny but persistent, catching the intervals between great telescopes. The object is faint, yet its meaning vast. For once, humanity prepares not to compete, but to cooperate, bound by curiosity rather than claim. In that shared purpose, our species reflects the same quiet grace we see in the sky, the calm persistence to watch and understand. Behind the instruments, coordination grows like architecture. ESA and NASA build a seamless relay of eyes and signals, ensuring no gap as Atlas drifts through multiple regions of the sky. Tracking centers exchange telemetry in near real time, balancing the rotation of the Earth with orbital positions. It is a ballet of mathematics, unfolding beneath silence. The goal is continuity. Every minute of light, every reflection, every variance in motion must be captured without pause. The European arrays provide daylight coverage when the American hemisphere sleeps, and then the relay reverses. This partnership, polished by decades of planetary missions, now carries a new tone. Not exploration, but observation of something that may observe us back. In that idea lies humility. The agencies coordinate not only through technology, but through shared wonder. The quiet agreement that some mysteries deserve no ownership, only patience. Continuous data means continuous connection. Each photon reaching a sensor completes a circle of attention linking Earth to sky. Scientists to object, presence to mystery. As instruments prepare, scientists simulate what the coming months might reveal. Spectral models predict shifts in the emission lines if the surface composition changes, or if active elements react to sunlight. A natural body should show gradual cooling and fading, while an engineered one might modulate light with purpose, reflecting patterns or periodic flashes. Observers plan to measure polarization, the slight twist of light waves that can betray structure or material. Even minor changes can alter understanding. A single spectral dip can speak of metal or mineral, ice or alloy. The analysis feels like listening to a coded song carried across vacuum. Hubble will catch the visual, Webb the infrared, ground telescopes the optical range in between. If the patterns repeat, then we may find rhythm, the fingerprint of design. If they remain random, then nature keeps her crown. Either way, prediction turns into patience, and patience into revelation. To measure light is to read intention written in silence. By late 2025, the campaign will aim for a single goal: to know what Atlas truly is. Every image, every spectral graph, every motion trace will converge on this question. If its core proves stable, metallic, and precise, we face the possibility of origin beyond biology. If instead it crumbles and fades, then nature holds her ground, and the mystery becomes a lesson in humility. But between those two extremes lies a gray expanse where meaning hides. Perhaps it is both, a hybrid of chance and craft, a seed drifting from one civilization to the next. The observers understand that truth may not come as answer, but as quiet expansion of imagination. Each measurement is both science and poetry. The universe rarely draws clear lines. Whether Atlas is machine or miracle, its presence forces us to look longer, think wider, and listen more deeply to what the cosmos whispers back. That is the real discovery. Not the label, but the awakening that follows the act of looking. Objects like this appear only across centuries, and even then, most never linger long enough to be studied. Atlas is different. It stays, and by staying, it invites us to understand. For every astronomer alive, this is a once-in-a-lifetime opportunity. To watch something from another sun settle under ours is to see time fold. Instruments may fail, models may diverge, but the moment remains, luminous and brief. In the vast darkness, we are witnesses to a bridge between worlds. The data gathered will feed generations of study, shaping how we think of travel, of matter, of meaning itself. Each photon that reaches a sensor tonight is already ancient, yet new to us. The cosmos does not repeat stories often. When it does, they are written in light and patience. For those who look up now, this is the chapter that will be remembered. The moment when a visitor paused, and humanity dared to ask what it meant to stay. The end of October leaves the sky suspended in quiet anticipation. A small wanderer glides between warmth and shadow. Caught between freedom and capture, astronomers hold their breath while tracking each flicker of its reflection. Every shift in speed, every faint deviation in motion, could decide whether it remains bound to the sun or escapes into the abyss. Nothing dramatic happens to the eye, yet everything depends on invisible forces. Gravity whispers, light measures, data flows. Humanity waits for a verdict written in numbers. The stillness carries meaning, for in that pause we sense how delicate fate can be. A single fraction of velocity may separate permanence from disappearance. If the traveler continues onward, it will join the few wanderers that brushed our world and vanished again. Its glow will fade across the black ocean, leaving behind a trail of silence and memory. Researchers will collect the fragments of its light curve, comparing notes from every telescope that glimpsed it. Each figure will hold a secret, a signature of motion that no longer exists. The fleeting nature of the encounter will become part of its beauty. Impermanence defines cosmic rhythm. The object will drift beyond reach, but curiosity will remain, orbiting human thought like a faint satellite of wonder. Even absence can teach, and loss can still illuminate. Should it stay, everything changes. The sun may claim this foreign body as a quiet companion, the first of its kind to settle among our planets. It would no longer be a passerby, but a neighbor. Decades of study could unfold, each rotation offering new detail, each reflection another clue. Its shape, its spin, its surface chemistry would reveal how distant systems forge their fragments. Scientists would find patience again, for discovery would not rush. It would be slow and precise, like the rhythm of tides in that still orbit. We would learn how stars share their stories, one captured stone at a time. Time would become a tool, not an obstacle. Instruments could be designed for long listening, missions planned without fear of missing the moment. Spacecraft could approach the silent guest, circling it gently, tracing every grain of dust it carries. The study would not end after a single pass. It would evolve through seasons and decades. Patterns of reflection could map its history, showing how interstellar matter endures across light years. Patience would turn into discovery, and discovery into quiet joy. The guest would become a living classroom, reminding humanity that the universe speaks slowly, and that true understanding requires time. If signs of purpose ever appear, the meaning will deepen beyond measure. A steady pulse of light, a deliberate adjustment in motion, and a mission that does not match known physics. These would hint at design. To witness such precision would change every boundary of imagination. Engineers would test propulsion models. Physicists would rebuild equations. Philosophers would whisper of intent. The silent visitor would become a bridge between thought and reality, proof that intelligence can survive the cold of interstellar distance. In its presence, we would see our reflection not in mirrors, but in movement and symmetry, in silence that speaks whatever truth emerges. Collaboration has already begun. Agencies once separated by politics now share observations under a single purpose. From ground-based telescopes to orbiting sensors, data flows in harmony. Each station becomes part of a greater instrument, a collective lens stretching around the world. The event has shown that science unites better than any treaty. When humans look upward together, boundaries blur. The shared search becomes its own kind of peace. The next era of exploration will remember this, not as a single discovery, but as a change in perspective. The night sky becomes a meeting place, not a frontier. Every cosmic moment invites reflection. The scale of the heavens humbles the mind, yet it also expands it. To witness something from beyond reminds us how brief and bright human life truly is. The fragile planet beneath our feet feels both small and precious. The silent body traveling through sunlight becomes a mirror of our own impermanence. Yet within that awareness lies calm. We belong to the same motion, the same cycle of origin and return. The more we see of the universe, the more clearly we sense that wonder is not far away. It lives quietly inside attention itself. Curiosity is older than civilization. It guided the first gaze at the stars and built the instruments that now reach beyond Pluto. It lives in the pulse of every question, never satisfied, always gentle. The interstellar guest rekindles that spirit. Each mystery it brings feeds the long flame of exploration. There is peace in inquiry, a rhythm that steadies the restless heart. To seek is to breathe more deeply, even when answers do not come. The act of wondering becomes enough. Curiosity itself is the vessel that carries us through darkness, always toward light. In the end, nothing truly concludes. The journey of the object will resolve, but its influence will linger across imagination. Scientists will continue to observe, and listeners will continue to dream. The lesson is quiet and enduring. Watch carefully. Wait with patience. Expect the unknown. The universe does not rush to reveal itself, but when it does, it rewards those who notice. The night will grow deeper. The stars will remain steady, and somewhere in that stillness, a fragment from another sun continues its silent dance. What happens next is already unfolding, softly, in the rhythm of time itself.